My name is Dhruva and welcome to another video of the series for Getting Started with Programming by Java the Huts. Today we're going to discuss how to improve your autonomous program with Roadrunner. Roadrunner is a powerful motion planning library for FTC that incorporates odometry, which is a technique used to track the robot's position and orientation on the field. By utilizing odometry with Roadrunner, you can create more precise autonomous programs that involve complex movement patterns. Here is how you can program odometry using Roadrunner in FTC. The first step is hardware setup. Ensure that your robot is equipped with an odometry sensors, such as rotary encoders or specialized odometry wheels. These sensors are typically placed on the drivetrain to measure the robot's lateral and longitudinal movement. Traditionally, teams utilize either two-wheel odometry with one parallel and one perpendicular wheel, or three-wheel odometry with two parallel wheels and one perpendicular wheel. Now, moving on to software, the next step is project setup. Set up a new FTC project using either Java or Kotlin. Include the necessary dependencies for Roadrunner in your project's configuration file, such as the Roadrunner library or the appropriate FTC SDK. Now we have to set up the odometry configuration. Configure the odometry parameters in your program to match your robot's hardware setup. This can be done in the standard traffic wheel localizer file. Ensure that the constants such as the ticks per revolution, wheel radius, gear ratio, and other constants match the physical specifications of the odometry setup. If you have the two-wheel odometry, the lateral distance is the distance in inches between the left and right odometry wheels, and the forward offset is the distance from the center of rotation of the robot to the perpendicular wheel. An easy way to measure this, the distance from the center of rotation, is use this piece of string, mark the distance with a marker, and then measure that length of the string. If you have a two-wheel odometry, the parallel x and the parallel y variables are the x and y coordinates of the parallel wheel from the center of mass. The perpendicular x and the perpendicular y variables follow the same logic. This won't be as easy to measure as a three-wheel odometry as you cannot use a string. The best way to measure this is to just use a ruler. And remember that for all of these measurements, the center of mass is 0, 0, and the values are essentially coordinates as they're negative or positive based on their position relative to the center of mass. Then make sure that your odometry pods are plugged into their respective ports, such as the left encoder is assigned to the left encoder variable, and so on. Make sure that you reverse the appropriate encoders such that when the robot moves forward, all the encoder's output encoder ticks in the same positive direction. Once that is done, add the following command to your sample mechanism drive file. Set localizer, new standard tracking wheel localizer, hardware map. It will also be down in the description so you can easily copy it. Now, this final step only applies if you have three-wheel odometry. Open up the sample mechanism drive and scroll down to around line 135. Then go ahead and delete the IMU. The IMU serves no purpose in three-wheel odometry, as its heading is calculated from the offset of the two parallel wheels, and the IMU initialization can take a couple of seconds when starting your op mode, which is unnecessary. The next most time-consuming step is tuning. For the sake of time, we'll not get into this video, but there's an extensive documentation on the Roadrunner website and a great community on the FTC Discord willing to help. Once your robot is tuned, the next step is testing a trajectory, which you should have already done a couple times during the tuning process. You can utilize Roadrunner's trajectory generation capabilities to plan and execute complex movement patterns. Design your desired trajectories using waypoints or spline paths that include the robot's position and orientation information. To make use of these paths in your autonomous program, utilize the odometry data from the Roadrunner website to guide the robot along planned trajectories. You can use Roadrunner's drive.follow trajectory method to instruct the robot to follow a specific trajectory. You also want to continuously update the robot's position and orientation using the odometry data in the main control loop of your autonomous program. This way, Roadrunner will provide updated pose information based on the position of your robot. Conditional statements and decision-making. Using conditional statements and decision-making logic within your autonomous program to determine when to stop or change the robot's movement based on the odometry feedback. For example, you can instruct the robot to perform additional actions once it reaches a certain position or orientation. Remember to refer to the Roadrunner documentation and examples specific to FTC for detailed implementation instructions. Additionally, take advantage of the community resources and support available through the FTC community to learn more about programming odometry using Roadrunner in the context of FTC. Use conditional statements and decision-making logic within your autonomous program to determine when to stop or change the robot's movement based on the odometry feedback. For example, you can instruct the robot to perform additional actions once it reaches certain points or orientations. This can be done through the use of temporal displacements or spatial markers. These allow you to perform either time-based, position-based, or distance-based actions, but are limited in certain areas. A relatively advanced method that allows much more freedom in the same regard is finite state machine following. Finite state machine following is a straightforward but powerful pattern that makes it very easy to orchestrate complex behaviors, and we plan on making a video on this in the future. But remember to refer to the Roadrunner documentation and examples of specific to FTC for detailed implementation instructions. Additionally, take advantage of the community resources and support available through the FTC community to learn more about programming odometry using Roadrunner in the context of FTC. If you enjoyed this video, please consider showing your support by liking the video and subscribing. Thank you so much for watching.